Okay, my dear students, today I would like to discuss how to find dimensional formula for tough physical quantities. Tough. Let us start from first example, which is called as easiest physical quantity. To let us go ahead with step by step tough physical quantities. First thing is, you know that F is equal to G m1 m2 by r square, and you need to find out the dimensional formula for G, which is called as universal gravitation constant. How are you going to find out this one? So very simple, that you write G is equal to F into r square m1 m2. So you need to find out the dimensional formula for G. So how are you going to find out that? You all know that F is nothing but m into a into r square divided by m1 m2. So dimensional formulas are same for masses, so we can cancel out them. Then the remaining things are G, acceleration means you know LT power minus 2. Here r is nothing but L square and this is nothing but m. Okay, so finally after simplification you are going to get G is equal to m comes to numerator becomes m power minus 1. This is going to be L cube and this is t power minus 2. Okay, so we got the dimensional formula for G. Okay, so next I would like to find out the dimensional formula for another physical quantity, which is called as viscous forces. Okay, so here viscous forces, the formula for viscous forces is nothing but, we can write it as 6 pi neta r Vt. Okay, so this is the dimensional formula for, this is the general formula for viscous forces. In that, according to dimensional concepts, there is no dimensional formula for constants. We will remove this one. There is no dimensional formula for constants. We will remove this one, and I am going to find out the dimensional formula for coefficient of viscosity, which is this value here. So therefore neta is equal to F into V, that is this is called as viscous forces, that's it. So divided by RVT. Okay, so V means thermal, V means terminal velocity, R is nothing but the radius, and force. So how are you going to find out the dimensional formula for force here? You know that force is nothing but mass into acceleration divided by radius is nothing but length here, and velocity is nothing but LT power minus 1, because velocity is nothing but displacement by time, which is L by LT. This can be written as LT power minus 1. Okay, so therefore the final formula I'm getting here is this one now, and all here acceleration formula is LT power minus 2 divided by L into T power minus 1. So LL gets cancelled. The remaining things for coefficient of viscosity is m L power minus 1, and this comes to the numerator becomes T power plus 1. Minus 2 plus 1 is going to be minus 1. Okay, so we got the dimensional formula for coefficient of viscosity. Now let me try to find out the dimensional formula for one more physical quantity, which is called dimensional formula for specific heat. If you want to find out, you should know one basic formula, which is called as, you know that Q is nothing but ms delta T. Okay, so you need to find out the dimensional formula for S. You will write this as Q by m delta T. Okay, Q by m delta T. Q is nothing but energy. Q is nothing but energy, or it can also be written as work. Work and energy both are going to be same here, and I am going to write the work as force into displacement. Force into displacement. Therefore energy is equal to force, which is taken as mass into acceleration into displacement. Okay, so work done means force into displacement, mass into acceleration into displacement. You will be writing this as mass is capital M and acceleration is LT power minus 2, displacement is L. Therefore the energy formula is ml square T power minus 2, and the quantity of heat energy or energy both are going to be same. So now I got the dimensional formula for energy in the numerator, that is ml square T power minus 2. Here this is also going to be mass. Okay, so this is also going to be mass here. Then what else we are going to do? We are going to find out the dimensional formula for temperature, and it can be given, there's a dimensional symbol for temperature is taken as K. or some of the books it is given even theta also. Okay, so now you can write this as m into theta or m into k, whatever it may be. So let us say k here. Gets cancelled. The dimensional formula for specific heat is taken as m power 0 L square and T power minus 2 here. Okay, so I got the dimensional formula for even little bit tougher physical quantity of heat. Okay, so you all know that PV is equal to nRT. You need to find out the dimensional formula for R, which is called as gas constant. So for that, first of all, you need to find out the dimensional formula for pressure, which is taken as force by area. Force by area, not acceleration, force by area. So force is nothing but mass into acceleration divided by area. So pressure can be written as mass, acceleration is LT power minus 2, and area is going to be L square here. LL gets cancelled. Pressure can be taken as ml power minus 1 T power minus 2. Okay, that is enough. And you know, volume is nothing but length into breadth into height, which is taken as L cube, because length is length only, breadth is also length only, and height is also length only, so it is taken as L cube. So what are you going to do here is you have to find out the dimensional formula for R. Therefore it can be written as P into V by N into T here. So P can be written as M L power minus 2 T power minus 2, and V is taken as L cube divided by N is number of moles. So dimensional symbol for N, which is taken as MOL, and for temperature, this is not time, this is temperature, and for temperature we can write it as Kelvin. Okay, so this T is taken as time and this is taken as temperature here. So therefore R, after simplifying, getting how much? M here, L power minus 1 3, 3 minus 1 is going to be 2, so we will write ml square, and this is going to be T power minus 2, K power minus 1, it comes to numerator, and this is taken as MOL power of minus 1. So this is going to be the complete dimensional formula for gas constant. For that you need to find out what is the basic formula first of all, and you know that the basic formula is PV is equal to NKT. Okay, this is called as Avogadro number and this is called as Boltzmann constant. For Avogadro number, as it is a number, it doesn't have any dimensions, so we need to find out what is K. Okay, so K is nothing but PV by T here. So just now I found the for pressure we got a dimensional formula, which is pressure is nothing but force by area, just now I found, which is mass into acceleration, which is LT power minus 2 divided by L square. LL gets cancelled. For this, pressure is taken as M L power minus 1 and T power minus 2. So we got the dimensional formula for pressure. Just substitute here. Now let us see what we're going to get here. M L power minus 1 T power minus 2, and volume is taken as L cube, and this is temperature, which is taken as Kelvin. Okay, so after simplification you will be getting the dimensional formula for Boltzmann constant as M L square T power minus 2 K power minus 1. So this is going to be the dimensional formula for Boltzmann constant. So dimensional formula for Boltzmann constant, isn't it? Yeah, Boltzmann constant, which is taken as, that is over, isn't it? Latent heat. How are you going to find out the dimensional formula for latent heat? You all know that Q is equal to mass into latent heat. Mass into latent heat. Okay, so quantity of heat energy. So this is the dimensional formula for quantity of heat energy is energy only. Energy and quantity of heat as having same dimensional formula. So this is the latent heat which we for which we have to find out the dimensional formula. We can take it as Q by M here. So this is the quantity of heat that can be taken as mass. This is energy. I told you that energy, the dimensional formula for energy, you can consider half mv square also, no problem. So here you can take mass as m and velocity is LT power minus 1 whole square. So dimensional formula for energy is ml square T power minus 2. So you can just substitute here, that is Q is nothing but ml square T power minus 2 and divided by m here, isn't it? So if you divide this with m, therefore there is no m here, so we can write it as m power 0 and this is L square and T power minus 2. This is going to be the dimensional formula for latent heat. Now let us go ahead to find out the dimensional formula for coefficient of linear expansion. So how are you going to find out that one? So coefficient of linear expansion, you all know coefficient of linear expansion is alpha is equal to increase in the length by actual length into rise in temperature. Okay, so length are having same dimensional formula, so we can cancel out length or change of length, whatever it may be, it is having the same dimensional formula which is taken as capital L. So this getting cancelled here, and temperature is taken as a symbol Kelvin, that is K we have to consider. Therefore this is 1 by K. Then there is no m, you write m power 0, no L, no T, but only K is there, we write like this here for coefficient of linear expansion. Then the next dimensional formula which we have to find out here, you all know that to find out the Stephen's law there is one concept here. What is that concept? You know that intensity is directly proportional to fourth power of absolute temperature. This is the concept behind what is said to be Stephen's law. Intensity of light coming from the sun is always directly proportional to fourth power of absolute temperature. This is temperature, not the time. Now if you write this I, then if you remove this proportionality, you will be getting sigma, and this is T power 4. This is called as Stephen's constant. You know intensity dimensional formula you have to find out. Intensity is nothing but power by area. Okay, and you also know that power is energy by time into area. You know the formula for energy. Energy you can consider it as half mv square. Half does not have any dimension. This is m. Velocity means lt power minus 1 whole square. So we can write this as ml square t power minus 2. So energy is having a dimensional formula ml square t power minus 2 divided by, this is capital T and this is L square. Okay, so L square, area means length into breadth, which can be written as L square. L square gets cancelled. Therefore we got the dimensional formula for intensity is m. There is no L, but T power minus 1, it comes to numerator, become T power minus 3. So we got the dimensional formula for intensity. So I am writing the dimension. Now you have to find out the sigma, which is called as Boltzmann constant, which can be written as I by T power 4. So I got the dimensional formula for I, and that is going to be m. L is not there, so L power 0, T power minus 3 is there, divided by T power 4. Okay, so T is nothing but temperature, which is given by the symbol Kelvin, that is K. So I am writing this K in the denominator, comes to numerator, becomes K power minus 4. So this is the dimensional formula for sigma, which is called as Stephen's constant. Now Wien's constant, what does it mean actually? From the sun, waves are coming outside, so we have to consider the maximum wavelength. Okay, so maximum wavelength is always directly proportional to absolute temperature. Okay, the maximum wavelength is directly proportional to absolute temperature. So lambda maximum can be taken as B into T. Okay, so where B is called as Wien's constant. B is called as Wien's constant. We need to find out the dimensional formula for B here. So B is nothing but lambda by T. Okay, so what is lambda? Lambda is nothing but length, wavelength it is actually, and here T is said to be temperature, we can write it as K here. So there is no m, m power 0, L is there, L power 1, T is not there, T power 0, Kelvin is there, K power minus 1. That's it. This is going to be the dimensional formula for a physical quantity which is called as Wien's constant. Okay.